Hap- Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Today's topic is on mechanics, and the subtopic is projectile. Please, before we go into the details of today's work, do not forget to subscribe to my YouTube. Kindly like, share, and comment too. Thank you so much. Now, first and foremost, want to discuss about mechanics. Mechanics is a branch of physics, and this mechanics is subdivided into two parts. We have the kinematics parts of mechanics, kinematics, and then we have what is called dynamics. Dynamics in mechanics. When we talk about kinematics is part of motion with net effects of force on the body being zero. What I mean by that is this: a body may be stationary or in motion, but that body is not being influenced by any force. Even if forces are acting on that body, the net force on that body will be zero. That means all the forces acting on that body will be zero. But when we are dealing with kinematics, this is the branch of mechanics that deal with the motion of a body such a way that the net force acting on such body is greater than zero. That means the body can be influenced by force, and we know that according to Newton's second law of motion, the second law of motion states that force acting on a body of mass m is given as mass times acceleration of that body. Let's say I have this body now. I apply this push on that body. That's the force. The body will move in this direction with an acceleration a in that direction of the force. So there is a net force acting on that body. In such a case, we are dealing with what is called dynamics. Now, today's topic, we are dealing with projectile. But kinematics can be divided into one-dimensional kinematic can be one dimension. When we talk about motion along ordinary x-axis, that is motion along a straight line. When the body is moving, let's say we have this body now, it's moving along a straight line, that is along one dimension. This line is represented with 1D. Now, another aspect of kinematics is motion along two-dimensional paths. In this case now, when the body is not moving just along this horizontal straight line, but the body is moving along inclined line instead of horizontal line, the motion can be studied this particular line can be made to be subjected to horizontal components, that is along the x, and the vertical components, that is along the y. So in a nutshell, what I mean by the components of this body, let's say this body is undergoing velocity u along this inclined line. If you put a torchlight here, this particular line can have a shadow along the horizontal. If you put a torchlight to this other side, this line can have a shadow along the vertical. So the shadow along the horizontal, if this line is inclined at an angle theta, the shadow of this velocity u of this body along this inclined line is given as ux, and us is this initial velocity u of the body times the cos of this angle of inclination to the x-axis, so u cos theta. Now, along the vertical, the shadow of this velocity u along the vertical is given as uy, which is this initial velocity u sine of this angle of inclination theta. So to make it look more clearly, clearer, to make it clearer, instead of me putting this body, I can just put the line of the velocity. So this velocity along the horizontal axis x, we have it as ux, and is given as this u then times cos of this angle theta, and the value of this u along the vertical axis is given as uy, which is u sine theta. So then the third kinematics can be along the 3D dimension. What I mean by 3D dimension is that when the body is moving in space, like for instance a housefly flying in the air, the motion of that housefly can be projected into 3 axes. Like for instance, let me say the housefly is moving inside this particular cube I have here. Let's say this is a cube. Now the side of this cube along the horizontal can be taken as the x-axis. Then the side of this cube that seems to move out of the paper, we take it as the y-axis. And the side of this cube, the height of that cube, we take it as the z-axis. Now let's say this is the housefly, this is the fly f in space inside this cube. Let's say this is the origin, and the fly move from this origin to this position P there. Now this particular velocity u of that fly can be subjected to the y component, can be subjected to the x component and z component. So in a nutshell, we say the motion is in a 3 dimension. The 3 dimension are the x dimension, the y dimension, and the z dimension. Now in our topics of today, which is projectile, that is a motion in 2 dimensions. Now what is a projectile? A projectile can be defined as a body in space whose motion is being controlled by force of gravity only. Okay, what I mean by force of gravity? Let's say this is a planet Earth. If you throw a body up, the body will fall down. This pulling force is called gravity. So gravity is the pulling force because the planet Earth has like a magnet that is attracting all masses towards itself. If you are here on the surface of the Earth, you throw, let's say you are at this point P, if you throw an object up, it will be attracted back by the Earth. So this force is known as a force of gravity. So in a nutshell, if you have planet Earth and then you throw an object into the air at an angle, the projectile, let's say it moves in this direction, the projectile that you threw will be attracted toward the Earth. So a projectile is a body in space whose motion is being controlled by a force of gravity. Example of bodies that can be called projectile: when a footballer kick a ball, the ball will move from the ground into the space. So that particular ball become a projectile, and this ball is being attracted as it's moving from different positions along a parabolic path. This path is known as parabola. So another one is a diver. When a diver want to jump into this swimming pool, by the time the diver jump on the diving board, the diver will be launched into the air and then dive into the pool of water. So when the diver is in space, we say the diver become a projectile. So we can have many examples of situations that we have a projectile. And before we discuss projectile, we should equally have at the back of our mind this resolution of forces along the vertical and along the horizontal. Let's say horizontal x. Let's say I have vector v. Vector, as you know, is a quantity that has magnitude and direction. Example of a vector can be force, can be velocity, can be acceleration, can be electric field intensity in physics. So let's say we have this vector v at an angle theta to the horizontal axis. If you put a torchlight at this place, when you beam a torchlight on this vector, it will cast a shadow on the y-axis. If you put that torchlight on this side of the vector, it will cast a shadow on the x-axis. Now, those shadows being cast on the y and x-axis, they are called the components of vector v. Now, the components along the x-axis is given as a vx. That means component of vector v along the x-axis. And that value is given as vector v cos theta, where theta is the angle of inclination to the horizontal axis. And the components along the vertical axis, that's the shadow along the vertical axis, is given as vector vy and is given as vector v sine theta, where theta is the angle of inclination to the horizontal axis. Now, with this background now, let's think about a projectile being launched by the a missile being launched by the army. Let's say this is a Nigerian army, and then we have the enemy on this side at this point. Now, this particular place that the Nigerian army is, we can put this in a horizontal direction. Let's call this x axis, horizontal axis. Let's call this place y axis. When the projectile is being launched here, it will go in a parabolic path. The path of a projectile is said to be parabola, and then it's a function of a quadratic equation. So the projectile will be like this. And don't forget that at each of the points of this projectile is being attracted by gravity towards the ground. Now, let's say the velocity of launch of this projectile is u. The component of this u along the x-axis is given as ux is equal to u cos theta. The component of this initial velocity of the projectile being launched along the vertical axis is given as uy is equal to u sine theta. Now, this is because I'm having x and y axis. This projectile motion is said to be a 2D motion, two-dimensional motion. Now, when we are solving exercises on 2D motion, we can break the motion down separately into the vertical motion and the horizontal motion. Now, let me start with the vertical motion. That is y. Initial velocity here, that is a uy, which is a u sine theta. As the body is moving toward toward the sky, it will reach a point that it will no longer move. We say the final velocity here will be 0. Now, we remember the uniformly accelerated motion. We know that the distance s covered by a particle undergoing uniform motion is given as initial velocity of that particle times time plus half times acceleration of that particle times the square of time. Now, in this case, the movement is along the vertical, that is along the distance y. So I will replace this s with distance y. Now, initial velocity of this along the vertical is u sine theta. So this u represent with u sine theta. Then times t that is there in the formula. Then plus half. In this case now, acceleration under gravity, we write it as g, which is 9.81 meter per second square, approximately equal to 10 meter per second square. So acceleration under gravity is g, which is given as 9.81 meter per second square, which is approximately taken in some calculations as 10 meter per second square. Now plus half g, sorry, t squared. Now if you look at this expression along the y-axis, we remember something that at maximum points, when y reaches maximum, the rate of change of the y with respect to time, the t, will be equal to 0. That means the body is no longer going upward. The body is no longer going upward nor coming down. So at this particular maximum point, according to calculus, dy dt is equal to 0. Now let's apply calculus. Let's find the derivative, differentiation of dependent variable y with respect to independent variable t. Dy dt, in this case, u sine theta would be taken as a constant. So we have it as u sine theta plus, when we differentiate t squared, we use this power to multiply and subtract 1 from that power. So in a nutshell, we are getting gt. Now at this maximum point, dy dt is equal to 0 at maximum. So when y is maximum, comma, dy dt is equal to 0. That is u sine t plus gt, you take it as 0. Now if you make t solve the formula, the t is the time taken for the projectile to reach the maximum height, and I want to tell us that the time taken to reach the maximum height is the same thing as the time taken from the maximum height to get back to the same horizontal ground that is the projectile was long initially. So the total time of flight t will be this t plus this t. That is t plus t, which is 2t. Please take note of this, total time of flight. Okay, now here, when we make t solve the formula, we have t is equal to minus u sine theta all over g. But because time must be a positive parameter, that means the g is negative. So we can rewrite this as minus u sine theta divided by minus g, which is u sine theta over g. That is the time to reach the maximum height, the time taken for the projectile to reach the maximum height. Now for the total time of flight, that means the time from this initial position of the projectile to the overall final position of the projectile on the ground is 2t. So we say time t of flight of the projectile, your t is 2 times t. That means the time taken from the initial position on the ground to the maximum height, which is t, plus the time taken to leave the maximum height and getting back to the horizontal level is same thing as another t. So t plus t is 2t. That's the total time of flight, and that is 2 times the t that we got before is u sine theta over g. So we can write it as u sine theta divided by g, which is 2u sine theta divided by g. So this is a total time of flight of the projectile. Now we want to consider the motion of this projectile along the horizontal direction. Now we can write this. This is the horizontal distance cover, and the velocity ux that we had in that diagram, the component along the x-axis is given as u cos theta. This particular velocity, that velocity is displacement. That is we can write it as x, displacement x, divided by t. is equal to u cos theta. So the distance covered along the horizontal is this x. So cross multiplying, making x all the formula there, I have it at, which implies that my x will now be u cos theta t. This particular t is the time the projectile cover anytime, I mean the distance the projectile cover at any time t is this t. For the projectile to cover the whole distance along the horizontal, my t will become total time of flight. So I can say x maximum. This x maximum is known as the range, and the range will now become u cos theta times total time of flight. And then, like I calculated already, total time of flight is 2u sin theta over g. So that means the range will now be u cos theta times 2u sin theta divided by g. Now range, now this x maximum, which is called range r, is given as I can rewrite it as u square times 2 cos theta sin theta all over g. Now from trigonometry, 2 cos theta sin theta is actually sin 2 theta. So in a nutshell, the range r can be written as u square sin 2 theta divided by g. That is the range. Now for the range to be maximum, the angle theta, this sin 2 theta should be 90 degree, because sin 90 degree will give us 1. So how do we make sin 2 theta to be 90 degree? Is by substituting 45 degree here. So that means for r to be actually maximum, the angle of inclination of the launch of that projectile must be 45 degree. So this is the part 1. I will call this topic as projectile part 1. In the part 2, I will show that the equation of a projectile is actually parabolic, which is a quadratic equation. Once again, my name is Orekoya Fumi Olusegun, Physics Mathematics Fundamentals on YouTube. Please do not forget to share, like, and subscribe to my video. Thank you and God bless you. Have a nice day.